For the last 3 decades, Knowledge Center at Bursa has offered technology, resources, services, space, and a sense of community. Since 1985, 14,000 titles have been collected, with care and attention to high financial literacy standards. In collaboration with a global community of institutions, we ensure access to the world's diverse intellectual and cultural economic heritage, as well as fast online services for connectivity to the financial world. Serving the Bursa Malaysia community and beyond, Knowledge Center at Bursa empowers you in your trading and investment analysis research.
Financial information at my fingertips.
Visit Knowledge Center at Bursa Malaysia today for the collections, for the services, for the sense of community.
You have suffered financial loss while investing, and you think your bank, broker, fund management company, unit trust management company, PRS provider or distributor, or their agent or representative is responsible. You need help sorting out the problem or want to seek redress. Where do you go? Sidrek is here to help you start the conversation and reach some resolution. First, lodge a formal complaint with a company that sold or offered you the unit trusts, shares, derivatives, or other capital market product or service. But you're not happy with their response. You have 180 days from their final written reply to come to Sidrek. Or if there's no written response, and it's been 90 days since you wrote to them, you don't need to wait longer. You may come to Sidrek even though you haven't received a final response yet. Sidrek first checks the eligibility of your claim. For example, is it within Sidrek's claim limit? Is it against a member of Sidrek? And so forth. If your case is eligible, we begin the dispute resolution process. All information in this process is confidential. We get both you and the member you're complaining against to sit with us and have a conversation. Documents and information will be required from both parties. No lawyers are allowed in the mediation process, as we keep the discussions informal and private. Our mediators are impartial and will hear both sides out and help parties communicate constructively towards resolving the dispute. 2 outcomes are possible at this stage. Either both you and the member agree to a settlement, or you don't. If the both of you agree to a settlement, an agreement is signed and the mediation process ends successfully. But if both you and the member fail to reach a satisfactory resolution, mediation has thus failed. But don't worry, Sidrek then proceeds to the next stage, adjudication. During adjudication, parties are given the chance to provide any further information to help their case and ask each other further questions. Our adjudicator will then study and consider all facts and information provided, including the conduct of the parties, laws, and best industry practices, as well as what's fair and reasonable. Sidrek's adjudicator will then make a final decision on the dispute and the monetary claim. If the decision is in your favor, it could be a full award or a partial award for your claim. But if the decision isn't in your favor, then no award will be made. You, the investor, will still have a choice. If you reject the decision, Sidrek will simply close the case and you may seek other legal avenues for redress. If you choose to accept the decision, however, the member has to comply with it. Once the parties have confirmed compliance to the decision, Sidrek will close the case. So let Sidrek help start the conversation towards resolution. For more information, visit sidrek.com.my or call 03 2282 2280.
Bursa Malaysia has been part of the Malaysian economic growth for over 4 decades. We have been working relentlessly to create a transparent, efficient, and vibrant stock exchange.
While we've been working at building a vibrant marketplace, inclusivity and contributing towards economic growth, we have also channeled efforts and resources towards supporting the community at large. Shares to Share is one such effort, which has been developed to create positive impact towards society and the environment. To put it simply, Shares to Share is a transparent and easily accessible facility that enables investors to donate their listed securities or proceeds from the sale of their listed securities towards charity through Yayasan Bursa Malaysia. You can donate odd lots or even board lots. The funds from the sale of these shares will be channeled to approved charitable organisations and their respective initiatives or projects.
Bursa Malaysia has waived its portion of the transfer fee, clearing and trading fees for all transactions that are conducted under Shares to Share. The participating brokers of Shares to Share have also agreed to waive their portion of the transfer fee and brokerage. The charitable organizations that have been selected have undergone the necessary due diligence process and have been duly approved by an independent selection committee.
At least 500,000 populations live with some kind of disability. They are most of the time being left behind. We need to empower them, otherwise they will continue to be the liability. A lot of human resources wasted from this group of people.
We provide a lot of support for persons with disability who are young adults and adults. We have a social enterprise called Project I'm Possible, where we managed to hire all persons with learning disability to work here. We have a cafe, bakery, weaving, and we have an art gallery.
Purity of thought, word, and deed, that is action, is very important to be really successful. We must know some skills to be able to help us then paperwork. The grant from Shares to Share will be used for, one is sewing, handicraft, classical dance, and so on.
Our patients have to be fed, they have to be looked after. We look out for any sort of disease they might develop, and also those unforeseen circumstances. Thanks to Bursa's initiative, we can be a little bit easy on our patients if they are family members.
Donations will all be channeled to organizations that are involved in the sustainable development of Malaysia. Shares to Share scheme offers you the chance to do so in a simple and effective way.
Bursa's Shares to Share allows us to do good by donating our shares to charities. To join us in making a difference to the society by donating your listed shares.
Shares to Share is open to all donors, individual as well as corporates or other types of entities. You can transfer your listed securities via Bursa Anywhere app at a click. For more information, please visit our Bursa Malaysia website.
Hello, everybody. Welcome to this webinar brought to you by Bursa Malaysia, and that's managed by our company LifeChamp. Today, our webinar title is EV Technologies at a Profound Inflection Point. So my name is Shen Zhu. I'm the moderator for this webinar. Now, electric vehicle industry is an exciting industry because there are a lot of new technologies that are put in place, and this is an industry that a lot of investors, especially growth investors, put the emphasis on because there seems to be a lot of growth opportunities coming from this sector. So today, we invited an expert, or some, rather, a full-time investor who has spent a lot of time and resources to study this space, to share with us what he thinks about this EV industry. Now, before we begin, as usual, disclaimer, whatever we share in this webinar is only for educational purpose. In no way that I give any recommendation for you to buy or sell any listed securities that we mentioned here. If you decide to make any investment decisions, you're 100% responsible for all your investment risk. Allow me to introduce our speaker today. He is none other than Mr. David Paul, who is the co-founder and managing director of Spiral Thinker Group. Now, David is a thinker, wealth creator, and value seeker. He's an engineer by training, is now a full-time private investor. He also serves as a portfolio consultant, and he's dedicated his time to advocate intelligent value investing, as he believes in long-term wealth creation with equities. So that is a brief profile from David. So without further ado, let's welcome David to our webinar today. So David, how are you today?
Hi, Shane. Thank you for inviting me back again. I do have to apologize because I'm feeling under the weather. A lot of my team members are down with COVID for the second time, and I'm suffering from some sort of complication on my throat. So I'll do my best to deliver a good show tonight.
All right. So pace yourself in this session, and thank you so much for coming to do this segment for us, even though you are feeling under the weather. Okay, appreciate it. All right,
no problem. So as you mentioned, I will try my best to deliver this, but I will speak a bit slowly today. All right, no worries. I have designed the slides to be more descriptive, so that you can refer back to the slides, to the video after the webinar if you miss out some things, okay? And but I just want to clarify something. Myself, I'm in no way an expert in automotive or EV. I pride myself to be a market observant. We invest a lot in semiconductor, and especially around the theme of EV and automotive. But you are right to say that this is definitely a growth sector that I don't think that any investor should, should ignore in the future, because this is definitely going to be an explosive growth in the market for this particular trend. And rightly so, now I believe that we are just at the inflection point. So I think this webinar is very timely. I'll explain again this session through a few topics, right? So we're going to start by talking a little bit on the policies as well as the market trends. And from there on, you understand why. Tonight, I want to talk about the wide bandgap semiconductors, or what we call WBG semiconductors. And then I will touch a little bit on ADAS as well. In fact, both of these topics are not foreign. We have touched on both these topics in the previous webinars before, but for tonight, I'm going to go much deeper into the WBG as well as the ADAS topics. So bear with me. Right now, I'm not going to spend too much time on case studies tonight, because most of the case studies are the same. But I hope that you pay attention, especially on the initial parts, because these are very important, right? Okay, now to start things off, let's talk about the policies, or what the policies that are shaping, the EV advancement recently, as well as the market trends. Now, as we know, the major factors that are pushing, the growth of EV is first and foremost environmental concerns, right? Thanks to social media, thanks to a lot of push from governments, thanks to the new generation, actually are growing greater awareness of why we need to protect the environment moving forward. So the key theme surrounding this is actually decarbonization policies, right? So whatever that we are seeing today, a lot of the growth, especially in the economy as well as the technologies, right, is actually driven by the decarbonization policies, Whether you're talking about solar, renewable energy, EV, net zero, all these are because coming from the decarbonization policies, which is a subset of the entire ESG framework, the environmental, social, and governance framework, right? And focusing on the E. But of course, you can talk all you want. If you do not have the technology to support this, it cannot happen as well. So the technologies for this has been evolving throughout the years, throughout the decades. And I believe that, we really believe that we are just sitting on the inflection point now before things really accelerate. Then other than that, of course, price must be correct. If there is enough policies, if there's a technology to support, to fulfill, to realize these policies, but the price is not right, right? The economic structure is not ready to support this. It is not going to happen as well. So that is why there must be a balance between supply and demand to support these decarbonization policies, especially surrounding the EV space. Okay, then of course, again, what are the policies that the policies which has been enacted, which have been enforced, including tax incentives, governmental programs, and most importantly, the industry player has to buy in this idea. They have to support these policies, because without the industry players, nothing can be done as well. All right. Then of course, with buy-ins, we need commitments from stakeholders across the board. Right. So that is why these are all the factors that are contributing to the growth of the EV moving forward. Okay. Now, next. Now, I know that actually, I don't know whether you realize, actually, for the past many years, the policies that are surrounding the EV is actually focusing on what we call the LDV, or light duty vehicles. That's why we have as the passenger vehicles, right? But moving forward, all right, as I will explain later on, there are more and more focus surrounding the heavy duty segment. So this will include your public transport. This will include your logistics, your vans, your lorries, your trains, so on and so forth. And with this, right, actually there's pushing the need, for the semiconductors content, which I will share a bit later, or share more in detail later. But what I want to highlight here is, from now until the next foreseeable 5 to 10 years, the focus will still be on the light duty segment. All right, light duty segment. Different countries have committed to different commitments, different time to realize this commitment. But this is please don't take it. Please accept that this is a variable milestone, so things can change. Case in point, I think just a couple of days ago, the Prime Minister of UK, I think Prime Minister Sunak, he announced that the Great Britain needs to push a little bit back for their net 100% electrified policies by another 5 years, from 2030 to 2035. Now, I know that he has gotten a lot of negative press about this, but if you ask me whether it's happening in 2030 or 2035 or somewhere after that, doesn't matter. What matters is the big trend is moving forward, right? And more and more countries are jumping on the bandwagon, right? Mark my words. And then, other than the light duty vehicle segment, in fact, the heavy duty segment is going to gain a lot of attention as well, and including the EVSE policies, which stands for the EV supply equipment. So it's not just about cars; it's about the infrastructure, the ecosystem that supports the growth of EV, right? Okay. So if you want to get more information about this, there's a lot of information from the IEA website. Please do visit this website when you're free, or if you want to know more about these policies. Now, then from policies, they'll come framework. So if you've got a good set of policies, you get a buy-in for industries. You also need a proper framework for things to happen, so that things can be realized systematically. So I'm not sure whether you heard about this. This is the KCASE, or CASE framework, which stands for connected device, connected vehicles, autonomous vehicles, shared or subscription-based, and electrification. Now, these are the framework that will drive the EV investments moving forward. We talked about the electrification framework before this, but this EV is much more than electrification. More and more attention is actually being poured, and more investments are actually focusing on the ADAS, which is the Advanced Driver Assistance Systems. And the theme now is these ADAS are not the typical ADAS that you and I know today. These are the AI-powered ADAS, very, very powerful, very advanced. And this is towards autonomous driving, or what we call FSD, full self-driving I think this is a term coined by Tesla team, right? And not other than that, other than the A and the E, actually there are many other aspects to this. So there is a connected, then there is a subscription as well. But of course, it may be too early to talk about this now. For now, I think if you can focus your attention and your resources, especially investments, into this A and the E framework, I think you should be set up pretty well already. Remember this. If there is one of the biggest takeaway from tonight, actually it is this slide. All right. Now, then from the CASE framework, where are the sectors or where are the areas of the market that will have the biggest growth? Now, I took this projection from Jeffries research just very recently. They published this research back in July. It's called The Next Upcycle Begins. Okay, now, so from here, as you can see, from 2021 to 2031, there's a span of 10 years. They believe that the long-term prospects of automotive chip makers remain very, very strong due to the mega trends like electrification, autonomous driving, increased confidence, safety within the car, so on and so forth, which is part of the case framework that we talk about. And among these, actually, the two segments that is projected to beget the highest growth is actually the EV or HEV. This is basically the electrification as well as the ADAS, right? Now, ADAS, according to this projection, from 2021 to 2031, is projected to grow at a compounding annual growth rate of 15% per annum. So, which means it's doubling every 5 years. For the 5 years, whereas the electrification actually will compound even a little bit faster than the ADAS, right? So that is why this explains to you, the audience, why tonight I want to focus on these two particular topics. Now, but of course, at Spiral Thinker, as webinars organized by LifeChamp, all right, and supported by Bursa Malaysia. Tonight is not the first time we talk about this. In fact, we have been talking about these topics or similar topics since 2020. I remember that the first time I touched on this topic is back in 2020 November, and interestingly, it wasn't a planned topic. It was something that was added at the end, and extra sessions. So I told Shane, I told Chun Sian that, hey, I think we should talk about automotive semiconductors because it is a growing trend. So in that session, I introduced, we focus on electrification semiconductors. We talk about MLCCs, we talk about MCUs, we talk about IGBTs. Then in 2021, because the response was very good from the audience, so we decided to dedicate 2 topics in 2021 to talk about EV or things that are related to that. So that is why in 2021 we had 2, and then the second session in 2021 I introduced a little bit about what is a wide bandgap semiconductor. Now tonight I'm going to further expand this topic to focus on the silicon carbide space. Okay. Now lastly, in 2022, I touched a bit more on battery technologies. So tonight I won't be talking about battery technologies. In other than WBG, I'll be talking about the ADAS as well. Okay, so without much further ado, make sure you stay until the end, yeah, because I've got a bonus at the end. Right. All of us know that silicon is at the heart of semiconductor. Why? The reason is very simple. because silicon is a great semiconductor. It is cheap. It is easily available. In fact, I think silicon is the second or third largest material in the world. All right. So, but silicon has a lot of limitations, right? Regardless of its benefits. So that forms the first generation of materials that form the semiconductor that we know today. And moving on, the second generation is actually where we have more advanced, or what we call materials called like gallium arsenide, indium phosphate, which actually powered a lot of the LEDs, the photovoltaic industry that as we know today. But the problem is with these compounds or materials is that they are very rare, all right? They're very rare. And unfortunately, they are very poisonous. And thus, it is, their production is actually quite hazardous to the environment. But we do not have any alternative for this now, right? There are very important materials in the photovoltaic cells, as well as other semiconductor components that we are using today, especially in the optoelectronics devices space. Moving on is where we have the third generation, or what we call the wide bandgap semiconductors. Now, it is actually a natural progression. Why we are moving from here to here, I'll explain the next few slides, all right? So in short, the wide bandgaps actually has a very specific electrical properties in their materials that allow them, that make them to become very suitable for applications in high voltage, high frequency, and they can sustain very high temperature environment. All right. Now, why are they so special? Right. Now, this slide is going to be a little bit technical, but I'll do my best to make it to simplify for you guys, because it is very important for you to understand what is the underlying framework. The underlying how a semiconductor works. Okay, now let's focus on this big chart first. As we know, there are basically two types of material, right? Number one, there is an insulator. Now, insulator are solid things that do not conduct electricity, meaning no matter what, how much voltage you pump into this material, it will never conduct electricity. For example, wood, for example, cement, all right, they will not conduct electricity. And why? The reason is because in every material, there exist two planes of energy, what we call the balance band and the conduction band. Now, the balance band is where, the atoms in the material sit still in layman's term. And whereas on the conduction band is the energy level where the electrons in the atom can freely move. And when electrons move, they carry current and thus completing the circuit. That's why they can conduct electricity. On the other hand, the conductor has the valence band and the conduction band intertwined together. That is why in any state or in any temperature, in any physical state, these materials can conduct electricity without any issue, without any resistance. Now, in between these two materials, there sits a very interesting middle ground, what we call the semiconductor, whereby the distance between the band gap, what we call, now the band gap is basically the level of energy that is required to push an electron from the valence band to a conduction band. But it does not mean that the electron has to move somewhere. No, it's basically just a energy level of the electron. So what can we do to excite or upgrade an electron from the valence band to a conduction band? We can apply, the energy can either come from thermal energy from the surrounding, or we can apply some sort of energy to the semiconductor to excite the electrons just enough so they can jump from the valence to the conduction band, and thus completing, having enough energy for them to conduct the electrons, to make the electrons move. and thus this is how electricity is being conducted. Now, as you can see here, there are a few elements that we can that I've showed here. Now, this also basically this is the band gap energy, the energy that is required to excite an electron from the valence band to a conduction band. Now you can see here actually silicon has very low band gap energy. So for silicon, this band gap is actually very, very narrow. Germanium has the lowest, but silicon is very near. On the other hand, diamond has a very huge band gap energy of 5.47 to be exact. So diamond has very wide one, which is very close to an insulator, which does not conduct electricity, right? Now, in between these, with a wide band gap energy of between 2 to 4 electron volts, sits these very special compounds called silicon carbide and gallium nitride. Now, of course, there are many other compounds that fit into these, but those that are very well known and easily producible are these, for example, here. All right. Now, one of the things, now you can study the electrical properties later on from here, but one of the things that I want to highlight is actually the critical field of the band gap semiconductor is called, which is denoted as the Emax. The Emax for silicon carbide is 9 times of that silicon, which means that the band gap of silicon carbide is 9 times bigger than that of silicon. Now you may be wondering, so what does that mean? How does that help silicon carbide to be a much better conductor, semiconductor than the silicon that we know of, right? So to explain that, actually, I want to talk about this slide, all right? So we studied from this spiderweb diagram, we highlight a few physical properties that are inherent in the wide band gap semiconductor that makes them so usable, so suitable in very specific application. Let's talk about the properties first. Now, wide band gap, I already explained this. Now, they have a much higher breakdown voltage. Now, this breakdown voltage is related to the critical electric field, which I talked about just now. So for SiC particularly, the critical field is 9 times stronger than the normal silicon. What that means is the silicon carbide material can withstand a much higher voltage compared to the silicon before the material breaks down. Now, we want to avoid the breaking down. Why? Because when the voltage is exceeding this breakdown voltage, the material becomes unstable. And when that happens, the semiconductor, the superconductor cannot be controlled, and thus the electrical system will break down. And we want to avoid that. So as you can see here, the electric field, silicon, all right, maybe I just magnify a little bit. Now, silicon has the lowest range here. Then actually the silicon carbide is much better than the end. Of course, the best is actually the gallium nitride. Now, later on towards the end of for this session, I'll explain why gallium nitride is not as popular as silicon carbide for now. Okay. Then other than that, now because of the higher electron velocity as well, now the silicon carbide as well as gallium nitride are much better at conducting higher, faster switching speed as a semiconductor compared to the silicon. Now, as well as the other parameters or other properties like they have a much higher thermal conductivity, means that the wide bandgap materials can operate in a much hotter environment, and plus because of the high thermal conductivity, they can dissipate the heat much better than the silicon. And this is very important because a lot of application now, especially in the industrial, especially in EV, especially in automotive, especially in space, we require these very specific characteristics for the semiconductor to perform as expected. Okay. Now, of course, these are the benefits, and that you can see here. Then these are the some of the sample compounds that which makes up the wide bandgap semiconductors. And from here, actually the most industrially, in terms of the industrial use application, the most suitable ones are actually the silicon carbide and the gallium nitride. Okay, now remember this is very important, right? So let's zoom in on the silicon carbide. Apologies. Now let's look, excuse me. Now let's look at this chart. As you can see here, this denotes the switching speed or the frequency, the switching, right, of the semiconductor that it can deliver. And on the vertical, this is the power that it can withstand or it can deliver as well. Now, for the silicon, actually silicon is very useful and it is widely accepted for low power and low switching frequency applications, like your day-to-day electronics, the computers that we know. But as we move on to applications or industries that require higher power and much higher switching speed, silicon cannot make it already. That is why, because of the properties that I explained just now, silicon carbide is actually more suitable. Now, as you can see here, silicon carbide can actually deliver more power compared to silicon carbide, and relatively they can actually operate in higher switching frequency as well. But of course, in terms of the switching frequency, GaN is definitely the winner here. So in terms of usage, as you can see, for the low to medium voltage applications, the GaN material, the GaN semiconductor is actually much more preferred. Now that is why I think a lot of you, I'm sure that you have known this very fast charging chargers for your smartphones, right? Whether you can buy it from brands like Ugreen, then you can see this very, I think, fast charging. You can charge your phone to 100% in less than half an hour, 20 minutes or so. And more often than not, these devices will have a GaN power chip inside. Then for the higher voltages, which is above the 600, 800 or 900 volts, this is where above these applications, the silicon may not be able to provide already. So that's why we need the SiC materials to support these high voltages applications. And because of these, there has been a lot of investments which has been focusing around the silicon carbide space, whether it is from the raw mat, from the processing, the manufacturing of the wafers, or so for you name it, right? And a lot of money has been poured into this space for many years. And I believe that we are just sitting on the inflection point, and the growth has not really started yet. So that is why I think now is the best time for us to look into this. All right, this is just for your information. Now, who was the company? Which is the company that actually first makes silicon carbide so popular? It is none other than Tesla. So back in 2018, Tesla, because they want to mass produce their Model 3, they were the first automotive player to adopt silicon carbide MOSFET. Now, before the emergence of the silicon carbide MOSFET power semiconductor, almost every automotive player, they were using silicon-based MOSFET or silicon-based IGBTs, insulated gate bipolar transistors, right? Now these IGBTs, they are good. I mean, they are suitable for normal automotive. But when it comes to EV, that requires much higher voltages, as well as requires a much stringent switching capability. The silicon-based semiconductors cannot make it ready. That is why Elon Musk, the Tesla team, were the pioneers to use silicon carbide-based MOSFET in their power inverters for their motors, as you can see here. So the IDM that supplied the transistors, the SiC MOSFET to Tesla, was none other than ST Micro. Now at that time, ST Micro had a contract from Cree, which is has already been bought over by Wolfspeed, right? So we supply the raw mat as well as the wafer to ST Micro, which then produces from using the wafer and the raw mat, the silicon carbide and semiconductors to be used in the Tesla Model 3, right? So this is what really kick off, the excitement about silicon carbide-based power semiconductors. So what's the deal about the recent announcement by Tesla or by Elon Musk that they say, oh, now we are going to use 75% less silicon carbide in the future? This news came out sometime in early March this year, and it caused a ripple effect throughout the industry, right? Those companies that are, or it has invested in silicon carbide, the share price tank. Companies on Semi, ST Micro, Wolfspeed, they all came down. But this news is, in my opinion, is already over sensationalized. But because if you don't study into the detail, you may be petrified, you may be scared. But if you look deeper into the technology, you will realize that actually this is a natural progression. Excuse me. This is the natural progression for the silicon carbide technology. Now, as you can see here, this is a slide by ST Micro, yeah. Now, ST Micro were the first power semiconductor, SiC-based power semiconductor to deliver the semiconductor chips, the power chips to Tesla, using the first, second, and third gen SiC power MOSFETs. And these are based on the planar technology, right? Planar technology. Moving on, it is a natural progression to move on to the trench technology, whereby physically, yes, you may use you may use a much less silicon carbide content because of the shrinkage of the devices. But that doesn't mean that the silicon carbide is not useful anymore. In fact, on the contrary, I believe that the importance that silicon carbide is getting more and more important because of this trench technology, right? As I will explain here. Now, basically, if you want to know what the trench, what the planar structure looks like, it looks like this. So, these are the silicon carbide substrate layer that you can see here, right? This is what we call the drift layer. Now, for the trench technology, it looks like this. So physically, it looks a little bit less compared to here, all right? But it is actually a natural progression. Why? Because the trench structure has a lot of advantages compared to the planar structure, whereby they can give a much lower on resistance. Now, naturally, any devices, they will have some sort of resistance for you to power on. So remember, switching is about on, off, 1, 0, 1, 0, 1, 0. So before you achieve 1 for the electron, for the circuit to complete and the current to flow through, the system must overcome this on resistance first, all right? And in this regard, the trench structure, the trench technology offers a much lower on resistance. And because of that, as well as other physical parameters and physical properties, the trench technology also can provide lower switching loss, because especially when you have a very high switching requirement. And because of these two combined, the device can be much smaller now. And because of this, that is why it leads to this Tesla announcing that in the future, they're going to use less silicon carbide material in their future cars. Now, I believe from our research, right, from industry experts like semi-analysis, fabricator knowledge, as well as industry players, that actually this is a natural progression. Why? Because in order for Tesla to be successful in their mass models, they have to bring down the cost. And one of the ways to bring down the cost is to make the devices smaller and lighter. Okay, so in this regard, ST Micro, from what I gather, is kind of struggling to achieve their next generation trench technology in their SiC MOSFETs. Other players have already done it. Now, Infineon is very interesting. Infineon was a late player in SiC, but they did not start in the planar technology. They straight away jump to the trench technology. And that is why Infineon, in the past couple of years, they have grown leaps and bounds in their dominance of the SiC technology. You can look deeper into this. There are a lot of things. There are a lot of investment opportunities surrounding this as well. But of course, there are other players like Rome, Fuji Electric, and so on and so forth. This, by all means, is not an exhaustive list. There are many players, right? Okay, so you can dig deeper into it if you want. Now, so where are these silicon carbide material used in the EV? So typically, these are the major subsystems where the SiC is being used. So we got the fast charging system, whereby the off-board charging. We got onboard charging for the AC, what we call the slow charging. The powertrain system, especially the inverters, uses a lot of silicon carbide materials. And this is just an example. This is the example of the inverter used by Tesla in the Model 3. Okay. Then, of course, other than that, they've got the DC to DC converter because you need to step down the voltage from the 400 or 800 volts batteries to the much lower voltage to power the subsystems in the EV. Okay. Now, so as I mentioned just now, one of the case study, very successful case study earlier is actually this company called Rome. They JV with this F1 racer company called Venturi, whereby they actually use their SiC module, their silicon carbide module in the inverter. So within a span of 2 seasons, they were able to reduce the weight of the power inverter from 15 kilo to 9 kilogram, whereby reducing the size to 30%, while maintaining the maximum power output of 220 kilowatts, right? So this is one of the use cases and why this is so important. Now, of course, other than the Tesla Model 3, more and more EV makers, the automotive makers are actually coming on to use silicon carbide in the lineup of EVs as well as cars. Now, as you can see here, this is the 400 volt range. This is 800 volt range. There are more and more focus on the 1200 volt range as well, especially on the heavy duty segment, which I explained earlier on in my slides, right? So other than Tesla, I think the other big adopters, the other major adopters of SiC include BYD, Kia, Hyundai, Lucid, so on and so forth. Now, one thing I want to highlight here is the more powerful is the requirement of the EV, which means that they require a much higher voltage system to operate in. They will require much more silicon carbide content in the EV, all right? So whatever that we know today, the mass model, right? Yes, they operate in the 400 range, but I think moving forward, there'll be more and more focus on the higher voltage range EVs as well. And this in turn will drive more demand for SiC, right? So now with the technology iterations, with more advancement in the technology, cost has to come down as well before the market, before the adoption can increase. So as we can see here, because of the iterations of the technology, whereby more and more scientists are joining the bandwagon, more and more players are coming into the picture, right? The silicon carbide cost of the die, the chip, or the die cost is projected to come down around 50% from 2022 to 2030. And I believe this will be a key factor to drive more adoption of the silicon carbide as the preferred power semiconductor in the EVs moving forward. Excuse me. So I'm going to take a bit more time to explain this because this slide will explain what are the major development that that gave me to came out with this title for tonight's webinar, where I believe that EV is just at the inflection point towards acceleration, right? Because of the advancement in silicon carbide, which will actually drive more adoption, more take up on this silicon carbide as the preferred material. Now, we do see a significant uptick in the shift in priorities moving forward. Previously, the focus is surrounding, hey, surrounding the workability of the silicon carbide. Can silicon carbide actually work or not? Is it really suitable? And technology has proven that it is so. So the focus is actually shifting from the technology benefit to the economical evaluation of the material to securing the required amount of material for future expansion, right? And because of this, there's a lot of changes in the market, especially the major players. They are trying to expand their market share through significant capex spending or M&As, right? Strategy M&As. Case in point, I think, as you know, I think from the recent news under the Anwar administration, you hear that Infineon is spending a lot of money in Kulim, right, to build a new capacity for the silicon carbide, right? So this is part of it. This is part of the 2 billion euro capex around the world, and we stand to benefit because Infineon has a very big plant up north near Kulim, right? SC Micro is also building their mega factory for their silicon carbide production. Wolfspeed is also expanding. Wolfspeed is actually perhaps the biggest spender in this space. And unfortunately, because they are the early adopter, and that's why I think they are suffering a little bit because Wolfspeed has yet to reach the optimum yield or production of the silicon carbide wafer and materials for the IDMs to use. Okay, now there are a lot of M&As as well, especially M&As to acquire technology, wafer technology, or even machines, from here, machines for cutting edge technologies to support the ecosystem, the ecosystem. Now, case in point, recently ASM acquired LPE for the epitaxial reactors as well as their intellectual properties. I think this is a very important milestone. And then just a couple of months ago, Vico acquired this company called Aviluvac, epitaxy player, for their chemical vapor deposition systems. And these are the development in the market that show us that actually there are a lot of serious money pouring into silicon carbide. And these are the development that will drive further adoption of silicon carbide. And thus, in return, the advancement of the EV technology, right? Now, of course, other than that, there is also a lot of talk, as I mentioned earlier on, from switching from planar to trench technology. And now they're talking about from doing a 6-inch to an 8-inch wafer to increase the yield. So all in all, you're looking at the big picture, right? With cost coming down, with better performance and higher adoption. Myself as well as my team at Spiral Thinker, we do believe that this is just, we are aligned. I think the market is just aligned perfectly from an inflection point towards acceleration in the next many years to come. Mark my words, right? So it is impossible for us to really decipher who are the players in this entire ecosystem. There are just so many players. But I believe that there is going to be a lot of consolidation moving forward as bigger players get more market share. They got more money to spend. There are more strategy M&As as well. All right. But you can study a lot into this. Actually, you can get this slide on your group. Your group is a very intuitive, very insightful resources. You can get a lot of information there. Now, but what you need to know is actually who are the major SiC wafer suppliers. There are people like Wolfspeed, Coherent, then the Chinese players. We got people like Tanky Blue. We got Sanan IC, which is getting a lot of traction these days because Sanan IC, they actually spend a lot of capex, and some of the companies listed in Malaysia stand to benefit from the expansion. Then we got other players like Soitec. Now on the epitaxy, we got players like XFab, who has a foundry in Sarawak, Kuching Sarawak. Then we got the major players for the chip processing, for the transistors, for the packaging, including Infineon, ROHM, SC Micro, so on and so forth. These are the major players. Okay, right. So this is what I'm going to end here for the silicon carbide. So I hope I give you a big picture of why silicon carbide is gaining traction, why they are so important in the EV, in the explosive growth of the EV. Okay, now give me a couple of seconds. I need to catch my breath here. Now moving on, I'm gonna move on to the next topic, which is ADAS. Now I'm not going to spend too much time on ADAS, but just to give you an idea, what are the components and why is ADAS getting more and more important, especially towards the full autonomy, right? Right. Now, as we know, ADAS is Advanced Driver Assistance Systems. All right, it is in short called ADAS. ADAS is not new. The earliest form of ADAS is what we call the ABS, or anti-lock braking system. I believe almost all the cars today would have the ABS installed in them. This is the basic ADAS system that we will have. Now, chances are if you have bought the new car in the past few years, you would have other features like the lane departure system, the warning system, the adaptive cruise control, the forward collision system, the pedestrian detection, so on and so forth. Now, these are the ADAS system which is already here today, and they are actually towards the autonomy target. They're actually, in terms of the safety level, they are basically what we call the level 0, level 1, and level 2 system only. Okay, lane departure, adaptive cruise control, and even I think that there are new cars that even have the traffic jam assist now. I think I'm not sure about the Proton X50 or X70 that you buy today. I'm not sure whether they have these, but I'm very certain they will have these as well. Now, of course, moving forward, we don't stop at level 3 because according to the Society of Automotive Engineering, they define 5 levels of autonomy for the industry to move forward to. So this is the expansion of this simple chart here from level 1 to level 5. So in short, level 0 is where the driver has 100% full control of the car, whereas level 5 is totally always controlled by the system, by the computer in the car, right? So in the level 2, they actually split up. Recently, they actually expanded the level 2 to level 2 plus and level 2 plus plus. Now, in my opinion, I think the same will happen to level 3 and level 4 when the time is near. So right now, with the level 2, we already have partial automation. Now, I'm sure a lot of you have seen the YouTube video of some of the Tesla drivers completely hands off the cars while they are driving, while the car is driving on the highway, right? So this is what we call the highway piloting system, where we have level 2 or level 2 plus kind of autonomy. Moving forward, naturally there will be more advanced autonomy, whereby we even have valet parking, full autopilot. In fact, there are actually some countries that already allow for full autopilot for a certain segment of the automotive sector. For example, robo-taxis. Actually, robo-taxis is considered the early adopters of the full autopilot system. Now, of course, the system is not perfect. It's far from perfect. I'm sure you have seen in the YouTube, whereby the robo-taxis are causing massive jam in very highly dense cities like New York City, right? So on and so forth. So believe me, there are still a lot of iterations to be fulfilled, to go through before we can find a working system, minimum issue working system. But it's going to happen. Now, of course, for these levels to advance, what needs to be there? What do we need in terms of semiconductor or the subsystem in a vehicle to enable this advancement in the autonomy level? Okay. So, in the layman's term, the increasing demand for ADAS will require, number 1, more sensors, and number 2, more cameras. And to drive these components, you will need more semiconductor. You need you need advanced processing chips, which I will show later, right? So basically, there are basically 4 types of sensors which is used in ADAS. We've got the radar, which is using radio wave for the ranging and detection. We've got LiDAR, which is using light or lasers, which is this LiDAR is called light detection and ranging system. We've got the camera, which uses visual, the image processing. Then we've got the ultrasonic as well, especially at the back, and these are using sound or what we call sonars. All right. Then of course there are other components which is designed to monitor, for example, the driver, the eye level of the driver, to see whether the driver is nodding off, to see whether the driver is sleeping. Then the ADAS system will trigger an alert or alarm to wake up the driver. Of course, last but not least, we got the automated driving system, which is still in a pretty early development stage today. Now, of course, today, with the limited ADAS features that we know, we will require mostly the radar, the camera, the sonars or the ultrasonic sensors. But moving on, as we move towards the higher level autonomy, there'll be more sensors and cameras or the ranging devices which will require to fulfill the demands for more advanced ADAS features. Okay. And other than the sensors, actually the computing power, the computing capacity also need to catch up, right? Because you can see here, today we are talking about 70 TOPS, or what we call tera operations per second. And when we are reaching full autonomy, I believe we will need more than 1,000 TOPS of processing power to enable this full autonomous driving. Now, of course, in this evolution as well, there is this thing called data fusion, because all these different sensors will give different inputs to the EV system, to the ADAS system. And these different inputs will require different types of processing as well as shown here. Now, for example, to enable adaptive cruise control, we need a long-range radar in front of the camera. For the shorter term, especially from the back, we require the short range radar or the medium range radar around the cars here. All right. Then for other features like the lane departure system, the traffic sign recognition, the surround view cameras, then we require cameras. Then for pedestrian detection, we require LiDAR. Now, there exists a problem here already. You see, this different sensor will give different types of input to the ADAS system. The radar is basically giving you, whenever you watch a movie, when the submarine goes under the sea, or when you watch the fighter plane, the movies like Top Gun, then when you use radar, right, basically you are using radio waves. So the input here, the signal is actually the radio frequency or the radio, what we call envelope, to feed into here. LiDAR will use the 2D 3D diagram to feed into. Camera is using image, and ultrasonic using sound waveform. So all these different signals have to go through what we call a sensor fusion so that the ADAS computer can make sense of what these are, and they can process the signals and provide the vehicle or the EV or the autonomous vehicle with the right corrective countermeasures. For example, whether you need to slow down, or you need to slow down to complete stop, or you need to accelerate, you need to turn. All these will come from this chip here. Now, this is the processor whereby you need to, this is broken down into 2 parts, the sensor fusion, as well as the ADAS, or what we call the autonomous driving machine learning AI platform. Now, from what I gather now of what is the accepted industry standard, FPGA is a de facto processor for the sensor fusion, whereby a microprocessor or a SoC would be the preferred architecture or the solution for the autonomous driving and the AI platform. Now, of course, in the future, this will change because there are a lot of study, a lot of advancement, development into this space. But unfortunately, I don't think there are any companies in Malaysia that are involved in this supply chain, not in a direct sense. But moving forward, I think this space will definitely expand, and there'll be more players coming into the picture. All right. So this is basically what is required for ADAS, and that is why the requirement for ADAS, the total addressable market, which is expected to grow at a very high compounding annual growth rate. So the key takeaway here is, with every progression in ADAS level towards autonomy, the semiconductor content per vehicle, whether it is ICE or EV, will increase in quantity. And this would benefit components like MCU, the microcontroller units, the microprocessors, the cameras, the radars, the lidars, and the sensors. Okay. Now, of course, as Spiral Thinker, we have already actually started monitoring this space since 2016, as shown from here. And but of course, at that time, there were very limited information or research paper that we can dig. And to be honest, that time there were not a lot of investment opportunities as well. Back in 2016, one of the companies that we highlighted was actually KESM, because I think back then KESM, the management already hinted about ADAS as the future technology that they are looking at. But of course, I think we were a bit too early in this investment thesis. So we lost some money in KESM, but I believe that with the development that I've shown you just now, so up to this point, I believe the inflection points are just on the horizon, and we are really towards the acceleration phase for both the WBG as well as the ADAS. Now, the ADAS ecosystem is even more complex because there are just too many players. You can download the very comprehensive ecosystem from this website called orsayconsulting.net. The link is here at the bottom, so you can go and look to this website for a high resolution copy. But basically, you can focus on the AV hardware, the autonomous vehicle hardware. But these are basically a lot of names that you know already. And in fact, we have talked about some of these names, I think, in our previous webinars. Companies like NXP, On Semiconductor, ST Micro, Denso, ARM. And then lately, there's a lot of GPU companies, AMD, the Xilinx, the company Xilinx solution, the ZF, so on and so forth, right? And I think this is not the exhaustive list. In fact, there's a lot more players here, but I believe that there's going to be a consolidation of this industry, right? So mark my words, this is a very exciting space, and I believe that there are a lot of investment opportunities, especially you have investment overseas and you have access to all these different investment opportunities. Okay, now 60 minutes. I'm going to move on to the last topic, which is the case studies. But as I mentioned before, because of our limited exposure in the KSE, I'm not going to spend too much time in this topic here. I think most of the case study that tonight I've already shared before. So there are the names like MPI, Penamaster, which I already shared before. They are still stand to benefit from this acceleration of the EV. But of course, there are new names like Division, ECA Group, which is recently IPO as well. And there are many players. All right. So I'm going to reiterate my case study on MPI because I think MPI has done a lot of inroad into the SiC space. So much so that they were criticized. The management was criticized recently for being too early into the game. But I think it is not so simple. It is much more than meets the eye, because in order for you to capture the market, you would you have to bite the bullet and be the first market mover, to be the first one to invest in the technology, so that when the demand does come, you are ready and you can start production right away. Because if you're not ready when the demands come, right, you may be too late already. So that is why MPI, the share price has taken a beating, which I will share later. So as you can see here, this is the roadmap of MPI. They come a long way from producing, automotive, very simple automotive packaging, to computers, to consumer devices, to sensors, and now to SiC technology, 5G, so on and so forth. So their focus now is actually on the power management as well as the EV. So these are the target segments based on their latest briefing that they say they're going to focus on. Number one, of course, they have their eye, they have their attention very much laser focus on the SiC adoption in EVs, as well as the sensors. So they are the MPIs who are going to be a major player in the electrification as well as the ADAS adoption for the EV growth. Now, other than that, of course, they are making a lot of inroads in 5G technology as well. Now, this is an old slide. This is a slide that they always share during the briefing, right? But what I want to focus here is actually the devil is in the details, right? So they actually have mentioned that they have been focusing a lot of their technology in the MEMS and the sensors, the electrification and sensorization wave. And as I have shown in the ADAS session just now, that the advancement, the adoption of ADAS require more MEMS and sensors. Now, MEMS is basically the semiconductor component that enables the sensors to work. But of course, to drive the sensors, you need MCU, and then to process as well, to combine all the data fusion, you need microprocessors. And this is how the story goes, right? So they are also making new design concepts for LiDAR and radar segment. For the power packaging, they have a lot of development for the SiC, for automotive, as well as the power management integrated circuits module. Now, other than SiC, they have already started as well on the gallium nitride as well. Okay. Now, this is from the latest briefing. Based on this is, I think, the M site in Ipoh. Basically, they have secured the bottom 2 floors for a Chinese customer. Then, from what I gather from the briefing, I think the top 2 floors are for future expansion, possibly for new SiC customers. In fact, they already secured a very, very big SiC customer for their S site already, which is also based in Ipoh. Now, the S site is actually currently undergoing expansion, whereby they are converting a lot of the car parks as well as the old production space for new testing and equipment space for SiC. I think I don't need to give too much hint. Their SiC customer is actually a major SiC wafer supplier highlighted here. So they are already signed a contract with this customer to provide the packaging solution for the SiC power semiconductors, right, from here. Now, because of their early entrance into the SiC, which did not take off, and which was flagged by so many bad news, right? Unfortunately, their share price took a beating, all right? So this is the case of double Davis attack, which I shared in my previous, which I mentioned in my previous webinars as well. So they were a victim of derating of their valuation, plus the slowdown on their earnings per share. I think the share price has gone down about close to 50%, 40% for sure. Right now, I think today, this is the price chart, which I snapshot last week. So I think the price is not too much different from today. The PE ratio, of course, based on historical earnings, is very high. But if their earnings can come back, can rebound, right? I think the PE should normalize to maybe 40 to 50 times. their cash flow yield is very impressive at 7%, despite the heavy capex requirement, and they are 46%, as I mentioned, close to 50% below their peak in 2021 of $50 or 50 ringgit already. So I see this as a glass half full. I believe this is an opportunity if you're a long-term investor and you want to benefit in the SIC growth as well as the EBITDA advancement. I think this is one of the companies that you should study in a very serious manner, all right, and a very good candidate for your investment. Now, of course, other than that, we've got other equipment players like Pentamaster. In fact, MPI publicly admit that actually they bought a lot of SIC equipment from Pentamaster, especially the Trooper series. All right, so Pentamaster, they've got wafer level equipment for which is actually designed for SIC wafer, or for burn-in wafer level burn-in testers for the SIC. They've got the Trooper B14. This is their star product. Then what I want to highlight here is, other than MPI as a customer, they are also trying to win other customers from China and from Europe, as I highlighted here during their latest briefing as well. I believe that they should be able to come out with more products, more testing equipments to supply for the SIC demand. So I believe that Pentamaster is one of the ATE players that will benefit from this SIC trend. Now, other than that, another major player which has recently been IPO is this company called ECA. Now, ECA, they have two major business units, the IPS as well as the SAE, standalone automated equipment segment, right? So in the standalone segment, they have actually they have a very good solution for IGBT. So I believe just give them time. In their roadmap, they would have included SIC or even GaN in their future roadmap already. So I believe that they should be able to benefit in the rising SIC trend, especially for automotive as well. But of course, there are many other players in the KLSC that are directly or indirectly benefiting or stand to benefit in the rising SIC as well as ADAS trend. Now, other than the MPI and Pentamaster that I talk about, Inari is also making inroads into automotive, especially in the photonics. Now, photonics is also used in ADAS, especially in the camera and the sensors division requirement, right? Unisem as well, because I think if you dig through my previous webinars, I actually use Unisem. I did talk about Unisem as a case study. They do stand to benefit because they have a lot of automotive exposure as well, although not as much as MPI. Now, Globetronics is a very interesting company. Now, Globetronics previously, the way I see Globetronics is they are very successful in reinventing themselves, redefining their business model from quartz timing devices to lighting LEDs to sensors. And after sensor, they actually been under the radar for many years. And recently, if you have been studying their annual report since last year, they already started to talk about data sensor fusion. Now, sensor fusion is, if you forgot about it, sensor fusion is this part. Now, I do not know how they will participate in this, but it is already mentioned in the annual report. Now, as Spire Thinker, we did reach out to the management, but unfortunately, the management did not divulge any information from regarding this. But I believe that if they get their new technology right, hopefully they get to redefine or reinvent themselves again. All right. Now, other than that, of course, the other players like Vitrox, QES, MIT Innovation, so on and so forth, Genetech, they all stand to benefit from this rising trend. Okay. So as a conclusion, I'm going to bring out a slide that I shared previously. Growth is always driven is always driven by consumption and policies. In this webinar tonight, I talk about the policies that are shaping the demand in terms of the demand as a supply side that will drive further consumption, further take-up rate for the EV, and which in turn will drive higher demand for materials like SiC, for the components which is surrounding the ADAS ecosystem as well. And from the McKinsey, this is another projection from McKinsey. Between 2021 to 2030, the vertical markets that will enjoy the biggest growth is none other than the automotive, electronics, and industrial electronics. So almost all the industry players, the research, professional research companies are pointing towards this direction. And that is why I believe as an intelligent investor, we should not miss this wave, all right? Now, there may be a lot of uncertainty now as the ecosystem is reshuffling to find its sweet spot. But with this kind of trend, right, I think it is wise for us to at least park some allocation into this investment thesis. All right. So before I hand over to Shane, a bonus slide for you all. Now I know tonight we talk a lot about SiC, which is, so SiC here is actually the orange color here. Why? Because of remember, SiC is a suitable third generation wide bandgap semiconductor for high powered application, which is required for EV. Now, mark my words, you know that at Spiral Thinker, we are always forward looking. In the future, GaN, or gallium nitride will become more and more important as well. In fact, the adoption of GaN starting in the next couple of years towards 2030 will in my opinion, will overtake SiC as well. From here. Now, sorry, actually this color is orange, but they are referring to GaN because I think I took them from different reports. Although currently the total addressable market, the projected total addressable market for GaN is much smaller than SiC. In the future, I believe that GaN is going to grow in their adoption, especially in automotive as well as industrial electronics. Right. But for now, it is enough for us to focus our attention on the SiC as well as the ADAS market. Again, so that ends my session for today. Once again, please accept my apologies for my broken hoarse voice. I've done my best. So I hope that you have at least captured a majority of what I want to share today. All right, over to you, Shane.
Thank you so much, David, for doing this very enlightening and informative session for us to understand the electric vehicle industry, despite you feeling under the weather. So thank you so much to David, and thank you everybody for being a wonderful audience, and thanks for your understanding for listening to David, even though sometimes you may not be able to hear exactly what he said. You may miss out one word or two, and thank you so much for your understanding. All right.
Yeah,
so David,
maybe I just want to clarify. That is why you notice that my slide this round has more words. It's more packed. And it is designed in such a way to give more information if you review the video from YouTube.
All right. Thanks for the very thoughtful gesture. All right. So for those of you who are asking, yes, tomorrow you'll receive a replay link in case that you miss out some points you want to play back. Tomorrow you will receive a replay link via your registered email address. So today we're going to keep our Q&A very short so David can rest early. So if any question to ask David, just put it there, but we'll only be able to manage maybe 1 or 2 questions. All right. So the first question is, in your view, David, if the investment idea is right, the silicon carbide growth, what are the advantages of investing into MPI over producers like Wolfspeed? Is there any concern for different silicon carbide producers to avoid using the same OSAT service provider?
Oh, Sam, sorry. Thank you for the question. So I would like to clarify, MPI, excuse me, MPI do not produce SIC. What MPI does, sorry, maybe I just go to the slide. MPI is a packaging solution provider for companies like Wolfspeed. So because as you see here, Wolfspeed, Wolfspeed actually is involved in the substrate, the SiC raw material production. They're also involved in epitaxy. They are involved in the chip design, the power MOSFET design, as well as the packaging. Now, when I say they're involved, it does not necessarily mean that they do this on their own. They would have outsourced some of the processes to companies like MPI, to OSATs like MCOR. There are many, many OSAT players in the region, not just in Malaysia, especially in Korea, especially in Taiwan. There are a lot of packaging. And MPI is just one of the packaging provider. All right, they have invested in SiC since a few years ago. So I believe that once the SiC adoption takes off and accelerate, API should stand to benefit. And I think that I do not need to be, I made it very clear enough already, very big hint that one of their customer is actually here. So Sam, I hope you get my hint.
Thank you, David. Now, David, both UNICEF and MPI have a plant in China. Do you have any idea why the MPI's profit dipped a lot more than UNICEF? Was it because of their exposure to the different segments or different customers?
I think to answer the question, you have to find out or compare how much is their China exposure between these two companies. From what I know, MPI recently made a lot of investments in China because they want to capture the SiC growth in the China market. Of course, they were met up with a lot of delays in their expansion. Their plant in Suzhou, their plant in Suxiang, as well as other regions, right? They were actually, because of COVID, because of the China lockdown, they did not advance as per plan. There were a lot of delays. So in that regard, I believe there were a lot of more negative impact on MPI compared to UNICEF. Then again, you have also to look at the shareholding structure between these two companies. Now, it is very hard for myself and my team to buy companies like MPI. Why? Because it is so illiquid. So when the illiquid stocks, when there's a lot of bad news, the share price will tank very fast. On the contrary, when good news happen, the share price can go up very fast as well. Yeah. So perhaps this is what I can answer to you.
All right. Thank you so much, David. Okay, let's do one last question by Janet. Would PMB Tech, which produces and distributes silicon metal products, benefit from the advancement of EVs?
Janet, this is a very good question. In fact, this is the question that I've been trying to ask the management during the AGS for the past 2 years. But so this is purely my personal opinion, because the management did not really give a direct answer. Now, the silicon that the PMB Tech produces are what we call the lower grade silicon. Now, in order to produce the silicon for semiconductors, so much for the automotive, you need a very pure silicon. Now, if they got grading when they got numbers, I just forgot what are the numbers. It's about the purity of the silicon, all right? So according to the management, they are trying their best to produce that kind of purity for semiconductor. Now, currently, they are indirectly benefiting the semiconductor space, but they are not a direct beneficiary. Those in time, in the future, if they put more investment, if they hire the right talent, they may carve more inroads into the semiconductor, especially the EV space. But to be honest, as far as I know, today at this moment, I don't think I would link PME Tech to the growth of EV directly. There may be an indirect beneficiary, but I don't think they are direct beneficiary. Yes, I hope I answered your question. And Janet, there are many other companies in KOSE that stand to benefit. I think you can just pick your choice. Thank you very much for that.
Thanks so much, David, for doing this Q&A session with us. So, ladies and gentlemen, you just heard from the co-founder and managing director of Spiral Thinker Group, Sundar Hart, who is David Poh. Thank you so much, David, for spending your time with us, despite feeling unwell today. For those of you who haven't checked out the Bursa Academy, you may visit www.bursaacademy.bursamarketplace.com. It's a one-stop e-learning platform that aims to give you a lot of financial and investment information. There are investment quizzes, coursework, articles, video recordings for you to learn about investing in Bursa Malaysia market. For our next webinar, it is titled The Top 3 Mindsets of a Good Investor. It's happening on the 4th of October. It is next Wednesday, 8:30 to 10 p.m. So if you want to learn how do you develop the right mindsets to be a good investor, you may register for the session that I've just given you the link in the chat box. All right. So if you have any more questions, you can forward it to alpha@spiralthinker.com. And David and the team will do their best to address your question. All right. So yes, David, you want to say something?
Thank you very much. Thank you very much.
All right. Thank you, everybody, for tuning in until the end of this session. Hope that you have gained enormous value from this session today, and hope to see you guys in our next webinar. Bye, everybody.